All right, welcome to lesson 4.1. So you should have your lesson 4 packet. You should have your yellow progress tracker. You should have a separate sheet of paper. We're going to be taking some notes and answering some questions on a separate sheet of paper. All right, looking at the first page of lesson 4, we want to think about how molecules could be absorbed through membranes in the small intestine. Absorbed is a new vocab word. So let's actually pause, look at the definition for absorb, and add it to our progress trackers. Okay, so we have 3 questions that we want to try and answer right on the front of your packet. And it's okay to stop and talk to a partner about this. But we want to, one, think about what discoveries we've made. What are some things that we've figured out? Next, what were the big questions that we came up with? Like, what questions do we have next? What else do we want to figure out? And what data would be useful for answering these questions? Like, what information do we need next to move forward? So, answer those 3 questions. All right, we're going to do some more what I see, what it means on a new set of graphs. So this is the I squared strategy. So we're going to identify, that's the what I see, and interpret, that's the what it means. So you have 4 graphs in your packet. So you're going to make observations. So draw an arrow to something you notice in the graphs, write what I see, and then write your observation in a complete sentence. And then you can share your observations with a partner. Then you're going to do the what it means. So really think about what we could interpret or explain based on what you see. So stop right now and make your observations and interpretations. All right, so some things we can look for. We have some patterns. So we're going to focus in first on the complex carbohydrates. So find complex carbohydrates on your graph. And then starting with the mouth, look at our levels. So healthy mouth is green on these pictures, McKenna's mouth is orange. So complex carbohydrates are the same in the mouth for both. And then when I move to the beginning of the small intestine, I have my complex carbohydrates are going down. So lots of glucose, less complex carbohydrates. And then when I get to the large intestine, for the healthy person, the complex carbohydrates and the glucose are both gone, but not so for McKenna. All right, now we're going to follow fiber. So if we find fiber, it's fairly low and the same for the healthy mouth, fairly low and the same in the small intestine, and low and the same in the large intestine. So, what do you notice as it moves through a healthy digestive system? And what do you notice as it moves through McKenna's digestive system? All right, make sure you have your separate sheet of paper. And we're going to look at poop. So, at the top of your notebook paper, I want you to write, how does this compare to our large intestine data? So, what is in poop and how does this compare to our large intestine data? So, take a moment and write that on your separate sheet of paper. So, what do you notice about poop versus large intestine data? What are the 2 primary molecules found in poop? And how does that compare to what's in the large intestine? All right, let's compare fiber to starch and glucose. So we have our glucose molecule, right? And then we have our starch molecule, which we know is made up of lots of glucose molecules put together. And then here's our fiber molecule in the top right corner of this picture. Fiber molecules tend to interconnect with other fiber molecules. So, what do you notice about the fiber molecules compared to starch? Yeah, the fiber molecules look like lots and lots and lots and lots and lots of starches all hooked together. They look very similar, but they are very big and complex. All right, I want you to record your answers to these questions on that separate sheet of paper. What is happening to the complex carbohydrates in the healthy data? What is happening to the complex carbohydrates in McKenna's data? What substance seems to remain constant, meaning unchanged, as it travels through the digestive system? And how do these graphs help us determine what we could expect to see in solid waste that leaves the body as poop in a healthy system? These should be answered in complete sentences, but you do not need to copy the question. All right, time to grab your yellow progress tracker. And I want you to go to our lesson 4 page, and you can work with a partner, but with words and pictures, I want you to represent or explain what the graham cracker and poop data tells you about what is happening in the large intestine in a healthy person and in McKenna. All right, here's our new ideas and questions to investigate further. So, on the back or at the end of your blank sheet of paper that you wrote your lab questions on, I want you to brainstorm with a partner ideas to these two questions. If big molecules can't be absorbed in the small intestine, why aren't there other big molecules besides fiber, like complex carbohydrates, coming out in the poop of healthy people? So we know we have big molecules, that complex carbohydrates like starch are big molecules, but they don't seem to be coming out in the poop like fiber does. What could be happening there? So, what's happening to those other big molecules like complex carbohydrate? How can we explain why the amounts of complex carbohydrates could be decreasing as food travels through the digestive system? What's happening to those complex carbohydrates?